So we're going to do a vector problem. And we have our 3 direct vectors. This is going to be a road trip. So first, before we begin, we have to define what way these vectors are facing. So the most important tool for this is going to be compass. And easily to remember, compass is V, right? So V and north, it's cold, south because it's hot, at least for me. Alright, so let's break down these vectors into their individual parts. This arrow at the top of the A means that it is a vector. It also has a direction component to the quantity. So, to break this down, we can break it down into AX, AY, and AZ. In this case, we don't have Z, so we won't worry about it. So AX, let's build ourselves a nice triangle. So this one says 35 degrees north of east. North of east, that means it goes this way. So, degrees north of east. And this vector is 20 kilometers. So, we can use our SOHCAHTOA so we have our hypotenuse, that's 20 kilometers. The sine is opposite over hypotenuse. Take a sine of 20. And that's going to be our y component. Sine of 35 degrees times 20 kilometers. Also, adjacent, which is this part right here, is going to be our x component. So this is going to be cosine 35 degrees times 20 kilometers. Do our math. Okay, so this one comes out to be 11.47 kilometers, and cosine 35. This is actually 16.38 kilometers, which makes sense that our x part is bigger than our y part. For this angle. Alrighty. Let's do B. That is west of north, so it is going west of north, and it's going this way. This is x, this is negative x, this is our y. So it's going west of north. That means the angle is going this way. And that's a 65 degree. So this is going to be our x component, and this will be our y. So the x and the y. We use our SOHCAHTOA once more. So opposite over hypotenuse, or hypotenuse is 30 kilometers. So this is going to be in this one, it's going to be adjacent to this angle, adjacent. This is cosine 65. Alright. So cosine 65 degrees. And also notice that this is going in the negative x direction, so our x is going to be negative. Times 30 kilometers. And B is going to be sine 65 degrees times 30 kilometers. So let's do our math. Alright. This turns out to be 27.18 kilometers. And this one. 12.67 kilometers. Alrighty. Does that make sense? 65x should be way bigger than y if this is 90. So that makes sense. Good. Let's do our last one. So we have 28 kilometers east of south. So it's going to go east from here of south. So it's going this way. Alright. And this is our third C. Alrighty. This time. Here, this is y, this is negative y, this is x, this is negative x, and we're going east to south, so we're going this way, 25 degrees, so it's relatively small. This is not small. Alright. Now, x, dy. So, in our SOHCAHTOA, opposite this time is going to be this. So this is our side. And this, adjacent, is going to be our cosine. And they're both negative. Notice, we can put those up there. So, and our hypotenuse is going to be there. So for y, this is going to be cosine of 25 degrees. Times 28 kilometers. Or for x, it's going to be sine 25 degrees times 28 kilometers as well. Alrighty. Calculate. Sine 25 times 28. Kilometers, and then for the y direction, cosine 25 times 28, 37 kilometers. Now, does that make sense? Our x should be quite small compared to the y. Actually, we're going in the positive x direction. So, change this. Always double check. It's just a good habit. But since this is extending this way, so turn this this way. That's what this one's doing. This one is going up. Lower. This one is going up and over. This one. So now you have to add the individual components. AX, BX, and CX. That's 16.8 kilometers plus 7.8 kilometers plus 11.83 kilometers. You notice this B component is actually negative. Negative sign in there. And that's going to turn out to be 2 kilometers. Now for our dy, AY, BY, and CY. Produce DY. So what do we have? $147 kilometers, it's positive, plus 4.67 kilometers, and then minus 25.37 kilometers. that gives us negative 1.20 kilometers. Alrighty. So this can now also form a triangle. This triangle, as the y direction is negative, go across. Negative, positive, negative, positive. In x direction, we're going 1 kilometer. This way, and then we're going down 1.2 kilometers. Down. So, this is going to be our triangle. Bam. And we need to find the distance here. It's going to be d. This is dy. This is dx. So, since we have dy and dx, we can use the Pythagorean theorem. A plus b plus c. In this case, this is just going to be dx squared plus dy squared which turns out to be 6 kilometers. So that is D, that is the hypotenuse of our vector. However, we do want to find out what's the angle. Now with the angle you have to be kind of careful. You have to select which one you want. So we'll want this right here. And this is our triangle. To be more explicit, we need to name it, which is east, south. So measuring east of south, the angle would be from our SOHCAHTOA tangent theta equals opposite over adjacent. The opposite is dx over dy, which is dx is 1 over 1.20 this is going to be inverse tangent. Inverse tangent of tangent inverse of 1 over 1.2. Because if you don't put the inverse, you'll get a different answer. Alrighty, so that's this is 39.8 degrees right here. So this is east of and how long are we traveling for? How long have we went? 6 kilometers. So we just put our vector back together. Bam. That will be our final answer. You could also report your answer counting from here, which would be 90, 90, 90. So, if you would like to record it like that, that would be 90 times 3 plus 39.8 degrees. Or, if you wanted to count your answer like this, you could take 90 minus 39.8 degrees. Look, this is 90. So that's it.